Hello everyone, welcome back to ptet.chemistry channel. So this is part of the Combined Science 5129 Cambridge International O-Level curriculum. So this was, this is what I'm going to use for a classroom revision. It basically just highlights what the syllabus actually is in terms of the questions and which part of the syllabus this actually comes from. This will have been different for your particular syllabus because this is for the syllabus 2023 exam onwards. So this is for the very new syllabus where the syllabus has been revamped. So it might be slightly different if you are watching this tutorial video from the all syllabus perspective. However, when you actually go through the questions, you would see that you can find the relevance to your particular syllabus of your particular year, your cohort, whatever year you are in right now. The questions will have been relevant to you one way or another. Okay, so yeah, let's go through the questions. They will have been a lot better, but what I just highlighted in the previous page was really just to show you that all these questions, they don't come out randomly. They come from the syllabus as part of the learning objective, where they say candidates should be able to do something, and if you didn't revise completely as the syllabus intended for you to do, if you didn't learn everything completely as the syllabus intended for you to do, then you're going to struggle. Okay, this is why a lot of combined science students struggle, not because they are not hardworking, but because they are not willing to actually cover the entire ground of the syllabus, or they did not use the syllabus when they are revising properly. Okay, in this first question, we have water molecules. We know that water boils at 100 degrees Celsius, so I hope you know water boils at 100 degrees Celsius. So that goes from liquid to gas, that is boiling. And don't forget that water also freezes. Oops, sorry, I don't mean also. I mean water freezes at 0 degrees Celsius and the ice melts at 0 degrees Celsius. So freezing point is equal to the melting point as part of the heating and the cooling curve idea. So what happens when you heat it up to 100 degrees Celsius? I'm going to sketch very quickly. So here you have solid, here you have solid to liquid, here you have liquid, and here you have liquid going to gas, and here you're already a gas. We are focusing on here. This is boiling, and when you have boiling, it takes place where the temperature is constant. Okay, the temperature is constant because this is change of state. Pure substance melts and also boils at a fixed temperature, or we say pure substance has a fixed boiling point and also a fixed melting point. So this happens at a fixed temperature. Temperature is not changing here. As you can see, temperature is constant here because you do not move faster. Okay, so you do not move slower. There's no change in speed, no change in speed during change of state because it's the horizontal line, so temperature doesn't change. If temperature doesn't change, then there's no change in your kinetic energy, no change in your speed at all. We're talking about heating, so when you provide heat, the particles will gain energy and not lose energy at all. Okay, eventually they escape from the beaker because, well, when they evaporate, when they boil off as a gas, they will definitely no longer be a liquid. They will escape from the beaker. Okay, question 2, which statement describe oxygen molecules? So this is oxygen molecules because it's not atoms, but really it's asking you, how does oxygen exist as at room temperature and pressure? You are definitely breathing in oxygen at the very moment. Oxygen is present in the air that you are breathing in, and that oxygen is present as a gas at room temperature and pressure. Room temperature is 25 degrees Celsius. If it is already a gas, the question really is, how does it look like as a gas in terms of kinetic particle theory? Closely packed is not true because you are a gas, so closely packed is out. Loosely packed because they are very far apart and they move randomly at very high speed. Vibrate above fixed position is wrong because that is for solid. So move around rapidly and also in random motion. That is the best description for gas, which you're breathing in oxygen gas at the moment. Number 3, so we're going to separate an insoluble salt. Insoluble means does not dissolve. The salt here is not your table salt, because your table salt, the one that feels salty, the one that you eat and put in food, that is soluble in water, but this one is insoluble. Salt is just a type of compound that we do in chemistry. So this is insoluble, does not dissolve. You have the salt and the water. Make sure that the salt is insoluble in water. So that means filtration is the way to go, because you filter the insoluble solid. So this one will be trapped as the residue. Residue is the substance left on the filter paper, or it could also be the solid that is left after you've evaporate a solution completely. Okay, so and then your filtrate is the water, is the solution that passes through the filter paper. So crystallization is not applicable here because this is insoluble, so you do not need to crystallize it out. Crystallization is mainly used to separate a soluble salt. If the salt is soluble, then you want to crystallize it to get both the salt as a crystal and also water. Distillation is to do with different boiling point. Typically, this is used to separate ethanol and water. So ethanol and water, or you can think about water, drinking water, which is pure water, pure drinking water from seawater. So you will encounter this as part of your classwork or homework. There are typically 2 examples. They are not the only 2 examples, but they're typically the 2 things that often come up again and again. Fractional distillation is slightly different from distillation because it collects multiple fractions, and this is to do with petroleum industry, and you will do more of this when you cover organic chemistry. This is partly what the Shell company does. When they get the crude oil from the ground, they will separate into many different fractions, because it's not just separating 2 things, it's separate many things, but the idea is still different boiling point. Question 4, this is called chromatogram because it's a result of paper chromatography. This is the yellow ink. This is P, Q, R, S, and T. When you put them into the solution, your solvent must be below. Your solvent must be below the what they call the baseline, BASELINE. This is the baseline. So you put your colored spot at the beginning here, and then the chromatograph, put them in the solvent will move upward, and then the dyes or the ink that is soluble in the solvent, the dye or the ink that dissolve in the solvent will move upward. But different substance move different distance. So you can tell here P separate into 2 spots, so P is impure. Q separate into 1 spot, Q is pure. R separate into 1, 2, and 3 spot, so R is impure. S separate into 1 spot, S is pure. T separate into 2 spots, T is impure. Okay, so I can say P is impure, Q is pure, R is impure, S is pure, T is impure. Okay, so which ink contain the color yellow? which inks contain the color yellow? So this is where you need to compare the horizontal level. This is the pure color of yellow. It traveled this much distance. So what does this mean here? P does not have a spot here, so P does not contain yellow. Okay, because this is yellow spot, P does not contain yellow. So P does not contain yellow. What else does not contain yellow? Q does not contain yellow. What else does not contain yellow? S does not contain yellow because there's no spot where the yellow has traveled to. Okay, you compare them horizontally. So which one contains yellow then? So you can see that R and T contains yellow. So it has to be R and T that contains the yellow spot. Okay, so you need to know how to interpret chromatogram. This is actually stated in the syllabus very clearly, that you need to know what it means by how far they travel up, what it means by the experimental setup, what it means by it's separated into two spots. So in pure, it's separated into one spot, so this is pure, and so on and so forth. Okay. So in this question 5, we have another question on paper chromatography, and this is another chromatogram, which you need to know how to interpret the chromatogram again and again and again. It says which one is a pure substance. In a chromatography, remember this is the baseline where you want your solvent. You want your solvent to be below the baseline, so your solvent cannot be above your baseline or on the baseline. Your solvent must be below the baseline for it to be correct, and then it will separate out. So if your spot was there, and was there, when you move upward, it will separate into different spots because they have different solubility. They dissolve to a different amount, they dissolve to a different extent in that solvent. So that's why there are two separate spots here. A has separated from one spot into two spots. This spot is more soluble in the solvent. That's why this spot moves further distance. It moves a greater distance than this spot. But what you can tell is that A is impure. A is impure because A separates out into two spots. B is pure because here B, there is no other spot apart from this one. B is the pure substance. A pure substance does not separate into two or more spots, it just has one spot. C is also impure, it's got 1, 2, and 3 spots. D is also impure, it's got 2 spots. It separates into 2 spots. That's what you explain. That's how you explain in a structured paper. Number 6, you're looking for a mixture. You're looking for elements, okay, 2 elements. So mixture of elements. Elements are pure substance, remember? And they only contains one type of atom. Only one type of atoms. But also remember that you cannot break elements down. You cannot break it down into simpler substance by chemical method. However, you also need to remember that elements can be molecules, but can also be atoms. Alright, so what we have here is, well, you have the white and the black representing different atoms. You have different atom, meaning different elements. These are 2 different elements chemically bonded together. That is a compound, so A cannot be the answer. This is an element because both the atoms are the same, even though they are chemically bonded together. This is a molecule, but it's an element because the 2 atoms are the same. This is another element because both of them are white. They are different from the other molecule where both of them are black. Alright, so here we have a compound just like in A, but this one, and also this one are 4 different elements. Okay, so I hope you can see that. I better change the color so that it's clearer without it all being red. Let me change it to blue. Okay, so what's the next one? This one is a compound. and then I can show you that this one and also this one are two different elements. Remember, elements can exist as atoms or molecule, and you have a compound when you have two or more different elements chemically bonded together in a fixed ratio. Okay, so we got our answer here, which is basically B. I spent longer than I should on this question. Ideally, you would be able to do this very quickly. Number 7. So we are looking at molecules. That's number 1. So molecule consists of two or more atoms bonded together. Now you are looking at gas. Okay, so you know the gas particles, in this case the molecules, not atoms, they are very far apart. They move randomly at high speed. This represents solid, so because they are closely packed, they are tightly packed together. So this represents solid. Here you can see this is molecule and this is atom. Okay, so the molecule here represent two or more atoms bonded together. Atom here, single atoms, but they're just one molecule, so we have atom and molecules. So this is not correct because we want molecules. Now between this and this, these are atoms, these are molecule. Okay, so here you only have atoms, no molecules. Molecule consists of two or more atoms bonded together. Compound consists of two or more elements bonded together. There's a difference between molecule and compound, and that's something you would have hopefully familiarize yourself with before you are at this stage. If you're still getting confused, it's worth it if you actually go through the definition again and again and again. All right. So next bit, we have information about a sodium ion. So we haven't really talked too much about sodium ion yet, but a sodium ion is Na+. The reason why you have a plus, it's a +1 because one more proton than electron. But it is still sodium. If it is still sodium, your number of proton is still 11 because your proton number is the identity of the element. So the element is still sodium, it doesn't change. So your proton number, which the other name for proton number is atomic number, doesn't change, and therefore your number of proton doesn't change. Now you have nucleon number. The other name for nucleon number is mass number. Mass number or nucleon number is the number of proton plus the number of neutrons. So working out the number of neutrons is going to be fairly easy. Okay, so number of neutrons is equal to nucleon number minus your proton number. I've spent quite a lot of time writing this formula down, but by right, if you can convert it into international format, you will be able to see that it's going to be like this: 11 proton, nucleon number 23. So nucleon number is this number on top, 23, minus the atomic number in this international standard, international form, which you can write on your own. That is going to give you 12. So X is 12, which means A and B are out. But what is Y? This is the very confusing thing, because you would have heard of me saying that in class the number of proton equal to number of electrons, but that is for atom. Okay, so when you have atom, for atom is uncharged. If you have an atom, the number of proton equal to number of electrons, but ions are charged. Okay, you have a look at the question carefully and you will see that it is charged. It has a charge of +1, so I must have one more proton than electron. So if I have +11, that means I must not have 11 electrons. I must have only 10 electrons. Then I will have 11 proton, 10 electrons. That means I have a +1 charge. Okay, so that is how it works with the formula of ions, and we will we will revisit this. So we will revisit this idea of charged ions very soon again when we come to chemical bonding, which is our next topic. But I wouldn't be too worried now if I were you, except that +1 means you have one more proton than electron. If you have 11 protons, +1 does not mean plus another electron. It means you have lost one electron because it's +1. So it's going to be y. So y is going to be 11 proton minus 1. You will have 10 electrons. 11 protons, 10 electrons. Okay, so you're gonna have 10. The answer is C there. Question 9. Question 9 is more straightforward. Atomic number is also known as proton number. It tells you how many protons you have in the nucleus of an atom, stated in the syllabus as something you must be able to define in words. Nucleon number is the other name for mass number. Nucleon number or mass number tells you how many protons and neutrons you have in the nucleus of an atom. These two are stated very clearly in the syllabus. If you write down the international format, proton number or the atomic number at the bottom, nucleon number or the mass number on top to the far left. Number of protons is going to be given by atomic number or proton number. Number of electrons, you see this word here, atom. Going back to what I said, atom is uncharged. Number of proton equal to number of electrons. If you have 18 proton, because there's the identity of argon, you must have 18 electrons, because +1, 18 of them, must be balanced right by -1, 18 of them, for the overall atom of argon to be uncharged. Okay. Number of neutrons is going to be the mass number or the nucleon number minus the proton number. Okay, so we're going to get 22. So proton is 18, electron is 18, neutron is 22. There's only one answer there. Number 10, you have this element potassium. So potassium, the symbol is K, is in period 4 but group 1. Okay, so what do we have for K? We have the mass or the nuclear number is 39. That's the number on top. The number at the bottom is 19. So this is the international format. After writing in these, I would work out proton, 19, electron. This is a neutral atom because neutral atom is uncharged. So number of proton equal to number of electrons. So what we have is 19 electrons. And how many neutrons do we have? It's going to be the mass number or the nuclear number minus the proton number. We will have 20 neutrons. Okay, so in this atom we have 19 electrons and we have 20 neutrons. So A is correct because they're asking for which statement is correct. 19 electron and 39 neutron is incorrect because neutron number is not equal to nucleon number. Okay, these two are very different. Does not equal. A lot of students get confused because it's N and N. This is nucleon. The spelling is Nucleon. Nucleon refers to the protons and the neutrons in the nucleus of an atom. This is Neutron. This is neutron. This is one of the 3 subatomic particles present in an atom. So 20 electron is wrong because that is 19 proton only. Okay, so 19 proton only for potassium. Therefore, must be 19 electrons for the atom. 39 electron is also wrong for the same reason. Okay, so be very careful. And of course, the number of neutron is as well wrong because the number there, atomic or the proton number, does not tell you the number of neutron. It tells you the number of protons in the nucleus of an atom. I hope you know this by now. That is in your syllabus. Okay, you are expected to be able to define it. Up next, we have some structured questions. So these are some diagrams representing how the particles are arranged. Of course, you should be able to draw any of these diagrams. Here you see them tightly packed, okay, can only vibrate about fixed position. Here you see closely packed with a little bit of space in between that they can slide, S-L-I-D-E, they can slide past each other. Here the gas particles are very far apart and they move randomly, they move in all directions, they move at very high speed. Okay, here you want the name, you want the change of state as stated in the syllabus. There are a couple of changes of state that you should have known. So for A, this is a solid, this is a liquid, and this is a gas. Read the question carefully. This A is going from liquid to gas. Liquid to gas is what you call boiling. B is liquid to solid, is what you call freezing. These are all stated in the syllabus, by the way. C is going from gas to liquid. This is called condensation. Condensation. All these are technical spelling, by the way. So which one of the following best describe movement, okay, in the liquid state? The liquid state is to do with sliding, okay? So just tick. The instruction is tick and one box. Liquid molecules slide past each other, and this one moving freely is going to be gas. They are very tightly packed. They only vibrate about fixed position. About fixed position means they are not moving around. They only vibrate about fixed position. That is going to be solid because they only vibrate about fixed position. This one is the gas molecules because they have possess a lot of energy. They are able to move randomly at high speed. Question 12 is about this kind of simple diagram representations of elements, compounds, and mixtures. So by knowing definitions, by knowing from your examples, by knowing where you went wrong, you should be able to get this correctly now. Okay, so each of these different colored things are different atoms. So here we can see this is atom. This is a compound because two different elements chemically bonded together. So that is a compound, and that is an atom. That is also an element. Okay, so you have an element and a compound. Here you have everything is the same type of compound. So that is definitely a compound, and all of them are the same type of compound. Here you have atoms. You have two different elements, but you cannot really say that they are bonded together because they are simply packed really close together. But this is regular arrangement, regular or ordered arrangement. So this is definitely what looks like a solid to me. This is an element, but it's also a molecule. Molecule because it contains two or more atoms bonded together, but the two atoms are the same, exactly the same. So you only have one type of atoms as stated in the definition. Okay, so this is an element because it's only one type of atoms. This is not an element. You can tell there's some black stuff. This is a mixture. Alright, so these are different atoms. Most of them are the white one, but some are the black one. Okay, you have an element in group 7. Okay, so this is group 7, like fluorine, chlorine, bromine, iodine. You haven't really done a lot of these yet, but eventually you will do after bonding. They exist as F2, Cl2, Br2, and I2. They exist as molecule at 25 degrees Celsius. So if we have chlorine in front of us, it will be Cl2 and not as an atom. Because of these are molecule. They have two atoms bonded together, and they are elements from the periodic table. Okay, so it cannot be Q because there are two different atoms. It has to be U because they are the same atom. Two of these are fluorine, two of these are chlorine, two of these are bromine, two of these are iodine. So it has to be U. Next one, you have a metallic element. Okay, you have a metallic element. Element is the key thing here. Only one type of atoms. All right. Here, metals do not exist as molecule. This is a mixture. This is a mixture. This is just one particular solid. Metals are solid at room temperature and pressure, except for mercury. All other metals, except for mercury, they are all solid at room temperature and pressure. So we're looking at as being a metal as a solid, and it's an element because it only contains one type of atoms. Okay. Brass. Brass is what you call an alloy. Alloy is defined as mixture of metals. Okay, mixture of metals. So what we have in brass is not going to be these, okay, because brass is a mixture. This looks like in a fixed ratio. Okay, this looks like a fixed ratio. Fixed ratio of atoms chemically combined together. This is actually an idea of compound, not a mixture. Okay, sorry if I said this was a mixture earlier. This is definitely a compound. This is a mixture because you can see the ratio is not, it looks like there's a lot of white, but there's a bit of the black one, so it's a mixture, whereas this one was not randomized, it was really ordered. Okay, so brass would have been a mixture of different metal atoms. Next one, a diatomic compound. Di refers to two atoms because diatomic, two atoms. Okay, it has to be a compound, and this is an element. This is not a compound because you do not have different type of elements. We are looking at these are all the same compound. They consist of two different elements and two different atoms chemically bonded together in a fixed ratio. So Q is a diatomic compound. Now we're looking at gases, and we're looking at a mixture of two gases. Gases, this cannot be gas because the particles are very tightly packed. Same for this and same for this. This is only one type of elements because all of them are the same. They are all the same element. This is the same compound. Okay, whereas this is a mixture. This is one gas, okay, and this is another gas, and two different gases because they are far apart, but they are mixture because this is not the same as that. So we're looking at P. Okay, so not entirely difficult, but not entirely easy. If you think this was just a random multiple choice questions, I think you must be mistaken. So you need to change the learning style and the learning habit of writing and circling and underlining part of the questions when you read them, because we are naturally very forgetful. The examiners will only mark this section. They don't care what you do to the question. So please start learning how to write, circle, underline question as you read. You are not allowed to use highlighter, so all you can do is just using your pen to circle. Do not do in pencil. Everything, all final answer is in ink only. Next question. So this is a question about filling in the table. I told you guys that in class they can ask you anything on relative mass and relative charge. Charge means there's a plus and minus. Mass, there is no plus or minus. You need to know the three subatomic particle and their spelling. Here they spell it out for you. Sometimes they give you the value and they want you to spell the particle out. Okay, neutron does not have any charge. Okay, protons are positively charged, electrons are negatively charged. The relative charge is -1. Proton and neutron have the same mass, so the ratio of their mass is 1:1. It's not +1, it's just 1 because it's not a charge. This is negligible. Negligible means you can ignore it, but typically this is what we will write down. Electrons are about 2,000 times lighter than proton and neutrons. Okay, electron is about 2000 times lighter. Lighter means lower mass than proton or neutron. Alright, up next we have to fill in a table like this. These are all atoms. When you have atoms, the number of proton must be equal to number of electrons, because atoms do not have overall charge. So whatever there is plus from the proton must balance out whatever is minus by the electrons. Fluorine, the symbol is F. Potassium, the symbol is K. Argon, the symbol is AR. Atomic number. The other name for atomic number is called proton number. We write international format, alright, with the proton number on the bottom left. So this is 9, this is 19, and this is 18. Okay, so these are the proton number or the atomic number. These are number of neutrons, and you know that number of proton plus the number of neutrons, and that equal to nucleon number. Nucleon number is also known as the mass number, which is a number you put on top there. Okay, so mass number is also known as nucleon number. So to work out nucleon number, you add protons and neutrons together. 9 plus 10 equal to 19. Okay, so here I have atomic number 19. Atomic number tells me the number of protons in the nucleus of an atom. So if I have 19 proton and 20 neutrons, so 19 plus 20 give me 39. Okay, now I have atomic number, which is the number of protons, so they are the same, but this is the number of neutrons. How many nucleon do I have? 18 plus 22. So you have to use the table and not necessarily from your predict table, because these are the data that are provided for you. Number of protons plus the number of neutrons give you nucleon number. Usually to find number of neutron, you would do nucleon number minus the number of proton. This is just mathematics. These are primary school mathematics. Number of electrons must be equal to number of protons for this atom to have no overall charge. I have 9 protons because atomic number or proton number tells me the number of protons in the nucleus of an atom, and I must have equal number of electrons for the charge for the protons to cancel out by the negative charge of the electrons. Alright. C. The following diagram shows an outline of the part of periodic table. So be aware, they bolded this for you. These are not symbol of chemical elements. These are not the symbols of the elements. So give the letter of the element, group 2 and period 3. So this is first row, this is period 1, this is period 2, this is period 3, this is period 4. This is group 1, so group is in Roman numeral. These are in Arabic numeral for the period. So this is group 3, this is group 4, this is group 5. So group 2, period 3 is going to be B. 14 protons in its nucleus. 14 protons. Well, if 14 protons in the nucleus, that means atomic number, which is the same as proton number, equal to 14. Now when you have element, you have atoms, right? So you have 14 electrons. Of course, you can go straight to the periodic table and you will see atomic number 14 is silicon. And from the electronic configuration, you will see that it's going to be 2, 8, 4. 2 plus 8 is 10 plus 4 is 14. First shell, second shell, and third shell is in group 4. It's in group 4 and it's in period 3 because first shell, second shell, third shell. First shell, maximum 2 electrons. Second shell, maximum 8 electrons. Third shell, 4 electrons. This is the valence or the outermost shell. Look for group 4, look for period 1, 2, and 3. So we're looking at C. C here is not carbon because they ask for letter of the element. These are from the table above, okay? From the table above, this is not carbon because exactly they ask you to read the question before you do a question. Part D, some of you might not be able to do it because I think one of the class hasn't really done this yet. But anyway, I'll just show you what it means. These are electronic configuration or electronic structure, or they call it electronic, I forgot what else they call it. But it's basically how do we fill in the shell? How do we fill in the shell with electrons? We want the element which lies directly below it. Okay, so they are in the same group but one extra shell. So you need to think about what is this. This one has 3 electrons in the outer shells. So this is what we call 3 valence electrons because the outer shell is the furthest away from the nucleus. This is the first shell. The first shell has 2 electrons. This is the second shell, which is also the valence shell for this element or this atom. It has 3 electrons. So the electronic configuration is going to be 2 electrons in the first shell, 3 electrons in the second shell. So that one tells you it's group 3, period 2, because first shell, second shell. It fills up to second shell, period 2. It has 3 electrons in the outermost shell, so it's got 3 valence electrons, therefore group 3. Okay, so group number tells you how many outer shell electrons you have, valence electrons. Period number tells you up until what shells do you have electrons in. Up until what shell do you have electrons in the shell. Okay, so below it is going to be 2, 8, 3. You want below it. So we start by drawing a circle. 2 electrons in the first shell, 8 electrons in the second shell, because second shell fill up to 8 electrons. Okay, and then 3 electrons in the third shell. Why? Because same group, directly below it, same group, meaning you have 3 outer shell electrons because group 3 as well. But you have 1 extra shell, so first shell, second shell, third shell, first shell, second shell, third shell. Here you fill up to second shell, here you fill up to third shell. Next question, we have this recently discovered element. You probably don't even have it in your periodic table. The chemical symbol is this. This is the international format. The number at the bottom tells you proton number or atomic number. The number on top tell you nucleon number or mass number. Both definition I've talked about again and again and again. They want the number of protons, so 107. Proton number tells you the number of protons in the nucleus of an atom. Number of neutrons, okay, I emphasize again, nucleon number is not neutron number. Nucleon number refers to the number of protons and the number of neutrons. So to work out the number of neutrons, you need to find out the differences. Take the difference of nucleon number minus the proton number. So show your working, because it's important to show working so that it's easy for you to do the work. This is number of neutrons. Now they give you an idea, so you need to read a little bit. It's a compound. Compound means consists of 2 or more elements chemically bonded in a fixed ratio. It has 1 atom of barium. This one is not in the periodic table, but the symbol is there. So it has 1 atom of barium, just pH. You can write 1. 3 atoms of oxygen, so O3. 1 atom of chlorine, Cl1. So what is the chemical formula? Well, it's going to look like this, or you can just write down without the 1, because without the 1, it means there's 1 of this barium, 3 of this oxygen, and 1 of this chlorine. This or this, they are the same thing. It's just reading the question. And can you believe it? They are giving you 2 marks for reading the question, for getting the numbers, for getting the symbol correctly. Okay? Question 14. So it brings a little bit. An atom of fluorine. An atom, one atom. When you have an atom, the number of protons equal to number of electrons because you have an atom. International format, 9 is at the bottom. So 9 is what you call the proton number. If you want, you can use the term atomic. They will both give you the correct marks. The one on top is what you call the nucleon number. If you want, you can use the term mass number. Both of these are definition again and again and again. Alright? So they say fluorine is a non-metal. How can you tell from there? Okay? So from the symbol, proton number equal to 9. Therefore 9 protons. So also have 9 electrons. Okay, so its electronic structure or its electronic configuration, if you don't like it, you can say electron arrangement. Its electron arrangement, or you can say electronic configuration, is 2 electrons in the first shell, comma 7 in the second shell. So that is the first shell. That is the second shell. So fluorine is in group 7. Okay, so on the right side of periodic table. Therefore, therefore it's non-metals. Metals are on the left side of the periodic table. Non-metals are on the right side of the periodic table in terms of what group is it in. Okay, so now electronic configuration of fluorine, or electronic structure of fluorine, is 2 electrons in the first shell, 7 electrons in the second shell. You should be able to play the snake ladder in the periodic table. The only reason why I put them in 2s is because it's easy to count 2, 4, 6, 7. Alright, and you should always write a symbol in between. Question 15. So we have elements in the periodic table. The atomic structure of an isotope of each of these elements are shown. So we haven't really covered a lot of isotope. In fact, I don't think we have covered isotope yet by the time we do this paper. Does not matter, but what is important is you will see what is important. Complete the table. Okay, so the number of protons is the atomic or the proton number. So what you could do is I can add 12 at the bottom. I could add 14 at the bottom. This one I don't know yet. This one I know is 17. Okay, this one I don't know yet, therefore I don't know the proton number. The electronic configuration is 282, so meaning that is first shell, that is second shell, and that is third shell. So total number of electron is equal to 2 in the first shell plus 8 in the second shell plus 2 in the third shell. I get 12 electrons. But remember, atom. Okay, these are elements that exist as only one type of atoms. Atom is uncharged. If you have an atom, your number of protons equal to your number of electrons. If you have 12 electrons, that's because you have 12 protons, because you have atom. Number of neutron is the mass number or the nucleon number. Okay, on top, so 24 minus the proton number, that will give you 12 neutrons. Here you get 14 because 28 minus 14 give you that. So here 34 is the nucleon number, minus this equal to 18. So how in the world do I get this? So number of proton plus the number of neutrons equal to the nucleon number. So the number of protons is equal to 34 minus 18. 34 minus 18, which is equal to 16. So this is 16 protons here, okay? Because 16 plus 18 will give you 34. You can test the idea. The atom is uncharged, so number of proton equal to number of electrons for the atom. 2 plus 8 is 10. 10 plus 6 is 16. So you could also get this by having 2 plus 8 plus 6, because you have an atom, number of electrons, total number of electrons equal to total number of protons, okay? If you have 17 protons, therefore 17 electrons for the atom, therefore is 2 in the first shell, 8 in the second shell. 2 plus 8 is 10. 10, after 10, the third shell can be up to 8 electrons. So 2 plus 8 is 10. 10 plus 7 is 17. So it's 2, 8, 7. This is in group 7, VII. This is in the third shell, because first shell, second shell, and third shell. Okay. Number of protons here is 14. So it's going to be 2 in the first shell, 8 in the second shell. 2 plus 8 is 10. 10 plus 4 give you 14. So this is in group 4. This is in group IV, meaning 4 for Roman numeral. And it will be in the third shell. First shell, second shell, third shell, meaning third period of the periodic table. 4 marks for completing this table correctly. Up next, we have some questions on separation techniques. So I have actually gone through this question. Okay, so for example, in these questions, so this particular lectorial will go through a couple of questions that derive from the particular concepts I covered in the previous lectorial. Okay, so in this question, we have a student who investigates a sample of rock salt. So the student grinds the rock salt into a powder. Okay, so grinds mean break it up into smaller pieces, and you grind it into very small pieces, powders. And you places the powder in a beaker, and you add water to it, and then you stir the mixture. Okay, so we apply some force and we stir the mixture to try and mix it, and then we pour the mixture through the apparatus shown. So this is very clearly a filtration apparatus setup. So if you can identify the apparatus, then you can identify the technique. Similarly, if you know the technique, you should be able to draw this from scratch. This is a scientific diagram to represent a filter funnel, and everything will flow through the filter funnel unless you have a filter paper. So this thing there is actually a filter paper supported on top of a filter funnel. Okay, if you don't have the filter paper, all of these can go through, because these have holes in between. The filter paper will trap the solid and only allows the solution or the liquid to flow through. So here you see you get a colorless solution. This is called the filtrate. Okay, these are all technical spelling. And the brown solid that is left over on the filter paper after all the solution has passed through the filter paper, you get all the filtrate, then you're left with residue which are left over on the filter paper. This thing is a conical flask, and you use a conical flask because it has a flat bottom and it has this top that can support the filter paper. Alright, so name apparatus A. Apparatus A is filter funnel. So I have just gone through all the apparatus setup instead of just going through for the question. Of course, in a real exam, you probably have one look at the question and you probably just jump straight to the question. But I'm not just doing the question for the sake of it. We're actually interested in learning about the whole apparatus setup, because it is actually a whole part of a story, okay? Rather than just talking about a little bit here and there. As I mentioned, a brown solid remains in apparatus A. That is what you call a residue. The residue is what remains on the filter paper, and you get a colorless solution collected. In that colorless solution is called a filtrate. Name the process to separate the solid from the colorless solution. You need to be careful here. The solid from the colorless solution. So we have a solid in here. Okay, we want to separate solid from colorless solution. We don't want solid from the brown solution. So you need to read the question carefully. You get this colorless solution. There is some solid in there. I want to get the solid from the colorless solution. Well, what we could do really is we could evaporate off all the solvent, or we can try crystallization. All right, so I would imagine that evaporation, or you can try crystallization. So both of these will work because it's used to obtain a solid from a solution. A solid from a solution, a solid substance that is dissolved in the solution, from the solution, either evaporation or crystallization. And in your specific learning objective, what have we got here? Well, they don't specify which one, but they like the term crystallization. So you could essentially use crystallization or evaporation. But since the syllabus specified crystallization, perhaps we should use crystallization instead of evaporation. So jumping straight into the experimental setup. So they've used a lid, okay, in order maybe to prevent the solvent from evaporating off, because we never know what the solvent is. It could be a solvent with a very low boiling point. So with a low boiling point, it can boil easily and it can escape easily, and you don't want your solvent to escape if it is volatile. Volatile means if it boils easily. Okay, this is the filter paper. It's supported inside a beaker, and what you have is this is the baseline, which you draw using the pencil. Okay, so this is drawn with pencil, and the solvent will slowly move up, and together with each of these pure substance, they will also move up depending on how soluble they are in the solvent. They will move further up if they are more soluble in the solvent. They will move slower, meaning they will not travel a great deal of distance if they are not so soluble in the solvent. With this mixture of dyes, it will separate out into the different components. They will move at different rate depending on the solubility in the solvent, and you have to compare them. Does the mixture contain whichever one of these A, B, C, D, or a mixture of them? All right, and we have to take out this filter paper, the chromatogram, before we can see the solvent move all the way to the very top, and we have to label it with a pencil. That is the solvent front. Okay, so here name the process the student uses to separate the mixture of dyes. This is the process, and this is definitely paper chromatography. So these are technical spelling. They are outlined in the syllabus a lot, so make sure you can spell them very, very carefully. Next question, it says the apparatus shown in the diagram is set up incorrectly. Explain why. I hope you can remember what I said earlier. The solvent must be below the baseline. Here you can see the solvent. This is the level of the solvent. So that is the solvent level, and that is your starting line. So I meant to see the contrast. So that is the baseline, and the baseline is below the solvent front, and that shouldn't be. You need the solvent to be below the baseline, below where you started. Okay, and that wouldn't work, because once you dip the baseline, which contain the dyes and the mixture, into the solvent, it will smear and it will not have an accurate RF, retention factor, and therefore it will not be an accurate paper chromatography anymore. Okay, so the baseline should be above the solvent level. Or you can do the reverse argument, because you say why is it incorrect, right? Why is it incorrect? You can say the solvent level is below, oops, sorry, not the solvent level, the baseline is below, the baseline is below the solvent level. This is incorrect. So either one is actually saying what is wrong with this experimental setup. Now you set it up correctly, and the solvent will travel up the paper. As you can see, your solvent should really be below the baseline, and you have this solvent front where you take out the chromatogram before the solvent is allowed to reach the very top. The solvent travels up the paper. and it will bring the dyes along with it. As you could see, solvent A goes up, solvent B is more soluble than solvent A in this solvent. That's why it travels a much further distance than solvent A. And solvent C also give you one spot, and solvent D give you one spot. If I think in terms of solubility, okay, solubility in this solvent, if I say going that way is more soluble and going this way is less soluble, so you will probably have to think about which one is travel the furthest distance. In this case, B travel the furthest distance, so B must be the more soluble. D for dog, travels the least distance in the same given of time, so D must be not very soluble in this solvent. And then after D, then must be A, then C has the next higher solubility. Okay, so I hope you can appreciate that how far they move depends on how soluble they are in the particular solvent. Now you have the mixture of dyes. I hope you can see that that corresponds to A. They have the same RF value. The distance moved from the baseline, okay, from here to here, divided by the distance from the baseline to the solvent front. It will be equal to the RF value of A. Alright, so it has A, and then it also has C. The mixture also has B, but the mixture does not have D. There's nothing there. Alright, there's nothing there in the mixture that contains D. So which of the dyes are present in the mixture? So it will be A, B, and C, but not D. Okay. In this next question, so I hope you can see these are longer structured questions, and these are probably easy marks to score because it's 2 marks and they give you 3 lines. So they need to be 2 important points of interest that are relevant to what they're asking. All right. So they want to separate ethanol from a mixture of ethanol and water. I talked about this in the previous lectorial, specifically in the context of COVID. Ethanol is an important solvent used in making hand sanitizers. All right, so the world was short of ethanol for some time because people couldn't get to work, and suddenly there's a huge demand for ethanol. So it's very important this particular process to separate ethanol from water, because you want the pure ethanol to give you sanitizers that are clean, right? Okay, so this ethanol is soluble in water. As you would know, ethanol is dissolved together with a little bit of other solvents, but ethanol can also be dissolved in water. That's why sometimes we see 30% ethanol, 60% ethanol. That means the rest are water, and it's not 100% ethanol. So we have a mixture. These two have different boiling points, and without going into too much details, you're not supposed to remember the number. Apart from water, the boiling point of water is 100 degrees Celsius. Ethanol has a lower boiling point than water. That is a very important concept to note. Ethanol has lower boiling point than water, and that means when I do distillation, ethanol, which has the lower boiling point, will turn into gas before water. So ethanol will turn into gas before water, and ethanol will be collected first, because ethanol will vaporize and it get condensed first. I will collect ethanol, and the temperature will be constant because I'm collecting ethanol at its boiling point, which is equal to its condensation point. So it's boiling here as ethanol, so the temperature at which you collect the ethanol will be the boiling point of the ethanol, and it's a pure substance. A pure substance has a fixed boiling point. All right, and then after all the ethanol has been collected, the temperature will continue rising and rising and rising until you reach 100 degrees Celsius. Then the water will start coming out, and you collect it in a different conical flask. This one says pure water here because this is not ethanol and water. This is a salt solution, salt and water. Salt has higher boiling point than water, therefore water is collected first. It's different when you have ethanol in water. Different scenario, you have to think about the different boiling point. So 2 concepts there, 2 points there. The first process is called distillation. In fact, we're talking about simple distillation, not fractional distillation. So it's just called distillation. Suitable because, so we just jump straight in. Do not repeat question, okay, because there will be a waste of time. Suitable because ethanol and water have different boiling point. So because they have different boiling points, you can separate out the one with the lower boiling point first. Different boiling points, so we can vaporize. Vaporize means boil. Vaporize means you turn something into a gas from the liquid. Vaporize or boil the ethanol first, which condenses first, because after you boil it, it will condenses first after you pass it through the condenser. Therefore, collect ethanol first. But the key thing really there is the different boiling point. Alright, so next question, what do we have? We need to describe, so with a longer wordy type of thing. So this is 3 marks now, and they give you 4 lines. This is also 3 marks and 4 lines. In each case, a suitable method to separate the named substance from the mixture. Okay, so here we have sodium chloride, which is actually salt, your table salt, the one we use for cooking, and sand. So we know sodium chloride is soluble in water. So this is what I mentioned in my other lectorial before this, and this is insoluble in water. Soluble in water means it's dissolved in water. Insoluble in water means it does not dissolve in water. Here you want pure and you want dry. Okay. So here we just need it to be a pure dry samples. In other cases, you might have seen pure crystals of sodium chloride. Pure crystals of sodium chloride would mean crystallization. Pure dry sodium chloride could also mean evaporation to dryness, or it could also mean you could crystallize it and then you dry the crystal, which means you have to filter a second time. After you filter off the first time, you get rid of the solvent which contains the sodium chloride, and then you crystallize out the sodium chloride, and then you filter the crystals again, and then you dry it again, which seems tedious, especially when the question is just asking for pure dry sodium chloride. So what I'm going to do is I will dissolve the mixture, because the mixture contains both of them. So dissolve the mixture of the sodium chloride and the sand. I will use distilled water. So the reason you're using distilled water instead of tap water, and we are specifying to be distilled, is because distilled water does not contain any other ions, and your drinking tap water might contain other dissolved mineral ions. So that's why in chemistry we always use distilled water, okay, instead of using the tap water, because distilled water has no dissolved ions. No dissolved ions, meaning it has got no other substances in it. It's as pure as just H2O water, okay, unlike your tap water. So dissolve that in distilled water, then filter off the insoluble sand, but we will collect the filtrate. The filtrate is the stuff, is the liquid or solution that pass through the filter paper. The filtrate contains the salt containing the sodium chloride. So I'm going to pursue evaporation here. So we will evaporate by heating the filtrate, meaning the solution, and we want to evaporate by heating the filtrate to remove the water, meaning the distilled water, leaving pure dry sodium chloride, which I can use the formula, but since we haven't really covered formula, by the time we do this particular topic, we can just write pure dry sodium chloride if I evaporate it to dryness, okay?